Hi all, welcome back. So in today's video we are going to discuss about scheduling semantics in system Verilog. So what is the scheduling semantics? Before going into what is the scheduling semantics, I am going to give a small example for you so that you can understand easily what is the scheduling semantics, and we are going to discuss about what are the things that we will be seeing in the scheduling semantics, right? So if you are new to this channel, please consider subscribing my channel and hit on the notification bell also, so that as soon as I will upload the video you will get the notification. And also you can follow me on all my Instagram and LinkedIn handles also. I have given that in the description box, and you can also join my Telegram channel where I'll be uploading courseware related to the topics that I'm discussing, and also I'll be uploading recent updates that I encounter in my LinkedIn profile, right? So let's not waste any more time. So what is scheduling semantics, right? So for example, if you are organizing an event in your college. Okay, so while you are organizing an event, if you want the event to be successful, what you will do? You will be organizing everything in an order. So in that way only, in system Verilog, while you are running the test bench, while you are developing the test bench in order to check the particular design, then in order to make the simulation smooth, right? So you need to follow this particular scheduling semantics. Basically, schedule semantics is nothing but rules and mechanisms that define how the changes in signal, that for example, if there is any change in signal, then is it happening in a particular order, or is it executed during simulation? Which signal to be changed first, which signal to be changed next? In this way, is it happening in an order or not? So in order to check all these things, that come under scheduling schematic. That means everything will be scheduled in a proper manner so that you don't encounter any unwanted situations. So what comes under this unwanted situations? Like you may encounter race around conditions, or you may encounter any mismatches happening. So in order to avoid all these things, you need to follow this scheduling semantics, right? Hope you understand about what is scheduling semantics. Okay, so this schedule semantics mostly describe how the simulator determines which events to be evaluated first, which event to be evaluated next. So in this way, whether everything is done in the simulation timeline, overall simulation is being done in its particular timeline, and which is doing first, which event is happening first, which event is happening next. So whether all this is happening in a correct way or not, this is done in this scheduling semantics, right? So basically, when you see in Verilog also, you have learnt about these events, right? In Verilog you have learnt about only four regions, is it or not? Right? So in Verilog you have learnt about four regions like active, inactive, okay, NBA and postponed. So these are the four things that you have seen in Verilog. Why? Because Verilog is a HDL. You will be used this to develop the design, but that is not the case in system Verilog, because in system Verilog you need to develop the test bench for the complex design circuits, and also you know that a system Verilog is a HVL, and also system Verilog is having lot other components when you compare it to that of Verilog. I have clearly explained about what is the difference between Verilog and system Verilog. If you didn't see that video, I'll link that in the description box. You first go there and check it out. Okay, right? So in this way you are having lot differences between Verilog and system Verilog, which is why when you are developing a semantics, scheduling semantics in system Verilog, these four regions are not enough, which is why it was categorized into some 12 regions. Okay, this four has developed into 12 regions in system Verilog, which is very important. Okay, when you enter into any interview, you can expect at least 2 to 3 questions from the scheduling semantics, right? So and also this is somewhat tricky to remember. Why is it? Because as I told you, scheduling semantics is nothing but which event is happening first, which event is happening next. So in this way you have to remember what are the events that is happening in active region, what are the events that are happening in inactive region. In this way you have to remember, right? So and also, which is why this is one of the most frequently asked interview questions. Clear? So, yes, as I told you, why we need to understand the scheduling semantics. Okay, as I'm telling from first, the scheduling semantics is very important. Why is it important? Basically, how if we know how the events are scheduled, like before doing any event, if you know what is the plan for that event, then you can organize it in a very smooth way. In this way only, if you know how events are scheduled, then there will be less less happenings of race around conditions. Okay, right? And also the test bench development will be very accurate because you know which event is happening when. Then the test bench design will be very accurate. And also the verification, when you are going for verification accuracy, it is also very accurate when you know about the scheduling semantics, right? So this is about scheduling semantics, and these are the regions that you see in your system verilog, right? First is prepone, pre-active, active, inactive, pre-nba, observed, pre-observed, reactive, re-inactive, postponed, right? Again, if you see here, these are 4, 5, 6, 7, 8, 9, 10. If you see here, these are 10. Again, here this pre NBA and pre observed is also again categorized into post NBA and post observed. Like two more regions are added in the further like in the further versions, right? So this is the basic version where only 10 were introduced, and later in the next versions the 12 regions were introduced, right? So basically these are the things that you need to remember. The first one is prepone region. So what are the things that that are happening here? If you see here, for your clear understanding, I have just highlighted it in a green color so that you can easily understand it. Okay, so basically, in this prepon region, what is happening means you will be writing assertions, right? Again, in assertions, you are having two types of assertions, like immediate assertions and concurrent assertions, basically. So, in this prepon region, the concurrent assertion values will be sampled. Like when you are giving values for the variables in the concurrent assertion, so these values will be sampled in the prepon region. Just remember that they are just sampled, they are not executed. Okay, that is the difference. They are just sampled in the prepon region, the execution will be done in another region. Okay, so this is how the events are scheduled in scheduling semantics. Okay, so this is the thing that is happening in the prepon region. What is that? The concurrent assertions are sampled, for the values of concurrent assertions are sampled in the prepon region, right? And also you should remember one more thing, which is this prepon region will be executed only once at a time. Okay, for every time slot only one time it will be executed. Somewhat similar to that of initial block. If you know about the initial and always block in Verilog, you know that initial block will be executed only once. Okay, in the same way prepon region will be executed for only one time for each time slot, right? So this is about prepon. And then comes pre-active region. So what is happening in this pre-active region is basically the PLI callbacks happen. Okay, the interface. Okay, PLI is nothing but programmable logic interface. Okay, this PLI callback will be happening, which will allow the user to read and write values and create events before evaluation of events in the active region. So basically what is happening in this pre-active region? Okay, so okay, I'll just give you a small idea on this pre things. So pre-active, anything here, if you see pre-active, pre-NBA, pre-observed, okay, if you see all this pre before the actual regions, they are nothing but just a warm up. Okay, for every match, for example, if you are going for, they'll be giving pre-matches or pre, so means nothing but before what is happening in the active region. Like, because in active region in Verilog also, you know that many executions will be happening in the active region. So before all these things are happening in the region, for example, if you see in the active region, module blocking assignments, okay, the blocking assignments will be executed in the active region, and the right hand side of all the non-blocking assignments will also be executed in the active region, right? And also continuous assignments will be executed in the active region. Inputs and output updates of Verilog primitives will be updated, and $display and $finish commands will also be executed in this active region. So if you see here, all these things like blocking assignments, module blocking assignment, that means nothing but assign, for example, assign S equal to A plus B. So you need to assign values for this A and B. So all these things like assigning values, okay, all these things are done in this pre-active region. But if you see in Verilog, everything is happening in active region itself, right? But as I told you, in Verilog you are having many other components also, so that is why this is further divided. Like, what is doing in active, what is being done in active region is, it is everything is evaluated in active region. Okay, now before the evaluation, if you have any assignments, or if you are going to like if you are going to write some $display and monitor, so all this assignment values and all those will be done. Like evaluation of events, everything which are evaluated are done in reactive, and then comes the active region where the actual work happens. Okay, they are just like warm up and actual thing, right? So this is about the pre-active. It's not only for pre-active, like for pre-observed and pre-NBA also, what is happening actually in NBA, that is beforely scheduled in pre-NBA. That's it, right? So this is this pre-active and active region. So we have discussed about three things: prepone, preactive, active. The next one is inactive. Basically, inactive also you know, because you have already studied about this active and inactive in Verilog only. So in inactive, those delays like #0 delays will be executed in inactive region. Mostly you will see the difference between these #0s and without giving any zeros. I have explained about this clearly in the fork join process execution. You can see that video. I'll link that in the description box so that you will understand the difference between without delay and #0 delay. So is there really any difference? If there is, then that is the thing, right? So the only thing that happens in inactive region is #0 blocking assignments are scheduled in inactive region, right? And then pre and BA. See, again I told you PLA callback control points, like read and write values and create events before evaluation of events in NBA region. Okay, whatever that are executed, that are evaluated and executed in NBA region, those all will be called in this pre NBA region. That is what is PLA callback control. That is, everything will be called before they are actually being executed. That means they, it is just like, as I told you, they are just being made ready for the execution, right? So that is pre NBA. So again in NBA, everything that is operated in LHS of the non-blocking assignment, those will be evaluated and executed in this NBA region. Actually the evaluation happens in active region. This execution will be happening in the NBA region, right? So I'm not explaining more about this NBA region, active inactive, because I have already explained it clearly with examples in the Verilog. Okay, I'll link that in the description box so that you can easily check that out and also understand about the four main regions mostly. Okay, right? That is NBA region, and then post NBA. Okay, pre NBA means getting ready. Now what is happening in post NBA? Okay, after non-blocking assignment is happening, if there are any other events that are scheduled that to happen after non-blocking assignments, those will be executed in this post and BA region. Right? Clear? So this is about post and BA. Next, observed. Okay, pre-observed is nothing but before observed what will be happening. Those will be coming for pre-observed. Pre-observed and post-observed. Because just like pre and BA and post and BA, if there are any events that were scheduled to happen after NBA, those will be executed in post NBA. Similarly, if there are any events that were scheduled in order to happen after observed region, then those will be executed in the post observed region. And pre observed region, just like you already have discussed about pre and BA pre-active, similarly pre observed also, whatever um, blocks that are being executed, whatever events that are being executed in the observed, those will be called by pre observed region. Right, now let us see what is happening in observed region. So in the active region, sorry, in the prepon region, we have talked that when we are assigning the values in the concurrent assertions, those values are being sampled in the prepon region, right? So these sampled values are evaluated in this observed region. Okay, so see, the concurrent assertions are evaluated which were sampled in the prepon region, those will be evaluated in the observed region. Okay, also clocking block inputs with explicit hash 0. Okay, we have discussed about this clocking block. Maybe I think I have discussed about this. If not, I'll be discussing it in the next class. So this clocking block inputs with explicit hash 0 step delay. So this will be sampled in the observed region. Basically, the clocking block inputs will be sampled in this region. Okay, the concurrent assertion which were sampled in the prepon region are evaluated, and then the clocking block inputs will be sampled in this observed region. Okay, during the evaluation, the pass or fail code shall be scheduled in the reactive region of the current time slot. Okay, so after uh, writing, like after getting the output of this observed region, like whether, because assertions means you need to know whether the assertion has passed or whether it has failed. So basically the output, it is evaluated in the observed region, but the output, like whether the assertion is passed or whether there is a fail in assertion, so all these things will be coming in the reactive region. Okay, right, after observed region, those the output, whether it is passed or failed, it will be coming in the reactive region. Right, so what is happening in the reactive region? Okay, so if you see here, mostly reactive region is very similar to active region. Now what you may get it out, like what is the actual difference between active and reactive. So basically, as I already told you, you already know since we have discussing from the starting. In Verilog, sorry, in system Verilog, everything is class based, but the connection between test bench and the RTL code. Like in RTL code, everything is module based, right? So along with this module, you are having also one other concept in system Verilog, which is program block. Okay, program block is very similar to module block. Okay, now you may prefer to write everything in the program, similarly everything in the module also. Now why we should inculcate program in our particular code? Because as I already told you, whatever that module does, the same thing that program also does. Whatever syntax that module follows, the same thing the program also follows. Then why should we use this program block? Basically, one advantage is, for example, if there are some statements, if there are some events that should not be executed in the active region for some consideration, like if you want some statements like dollar display, dollar finish, so these are the statements, basically they will be executed in the active region. Okay, and some blocking assignments. Okay, so there may be some blocking assignments which you don't want to be executed in the active region. Then if you're writing in blocking statement, obviously they will be executed in active region, but you don't want that to happen. Now what can you do? You can write such execution, such events which you don't want to be executed in the active region in the program block, so that this program block will be executed in the reactive region. Clear? So after execution of all these things, like after execution of active, pre-active, active, inactive, pre-NBA, NBA, post-NBA, pre-observed, observed, post-observed, after execution of all these states, then the reactive happens. That means then if you want statements or events to be executed at that point of time, then you can include all those things in this particular reactive, in this particular program block. Okay, so hope you got it. Basically, whatever that you written in program block, and what are the pass fail codes from property expressions, like before, as I already told you, like in observed region, the concurrent assertions will be having some pass fail conditions. So what are these pass fail conditions, and also what are the statements that you are writing within the program block? So all these are scheduled in the reactive region, right? So when it comes to reactive program, the same, just like the active block only. If you see here, programming blocking assignments, instead of module blocking assignments, you are writing program blocking assignments. Okay, pass or fail from concurrent assertions, this we have already discussed. RHS of a program non-blocking assignments, if you see here, the same thing here. RHS of all non-blocking assignments, but here everything is module based. That means when you are writing anything within module, then all those statements will be executed here. But when you are writing something within program block, then those will be executed in this particular block, right? We'll also discussing about how we'll be writing about the program in the next session, so please don't miss that out, right? So again, program continuous assignments, everything is program based here. If you see, okay, everything is same like active region, but the only difference is active, in active region all module based events will be executed, in reactive all program based events will be executed. That's it. Here executes the $exit and implicit $exit commands, right? So there $display and $finish will be executed, here $exit will be executed, right? So this is about the reactive region. Okay, then, okay, before reactive we are having post observed. Post observed I don't want to discuss, because similar to that of pre-active and pre-NBA. Okay, post observed, like if you see, post observed means whatever that are happening after the observed region, so all the things those will be evaluated, right? And then postponed region. Okay, this postponed region is used for PLI callback patrol, that allow user code to be suspended until all active, inactive NBA regions have completed. Okay, basically if you see, in this particular thing, all entire everything will be after completion of all these events, like active, okay, inactive, NBA, observed, reactive. So after all the events are happening, then comes this postpone. Okay, so after the postpone, it will go to the next time slot. Okay, so within this postpone you is already present in Verilog also. So basically in this postpone, $monitor and $strobe will be executed. That is why when there is any change in the value or any change in the variable, you can easily observe it in the dollar monitor, but you can't do that in the dollar display. Okay, that is the reason. And also when you go for dollar stub, only the last execution of value will only be present in the dollar stub. Why is it? Because these will be the last to be executed, right? So that is why these values will be having the last values. Clear? So this is about the scheduling semantics within system verilog. So this is a simple way, like in order to remember, you can just take the snap of this, so that you can easily refer to it when you are going into any interviews or any other things related to system Verilog, right? So this is all for today, and in the next class we are going to discuss about program law. So please stay tuned for it. If you like this video, please do give me a like and also share this video to all the VLSI aspirants who also want to enter into design and verification domain. That is all for today. Thank you all.